In this video, I am going to show the functionality of my onboard BIOS updater. So real quick, I'll turn on my system. And when my system boots up, you can now see this screen that I bring it up to. So I just kind of show a BIOS version, which I'm showing .0001. That is the current version that it's on. And with this current build, I can do things like type vir, and I can type help, and it just gives me information about things that I can do at this point, which obviously there's not much there. I can hit help, I can hit vir, I can clear the screen, and I can update the BIOS. And that's what I'm going to show in this video is the update BIOS. So over here on my computer, I have this 286 code that I am working on, this assembly. And it has a fair amount to it at this point, at least for me. So I don't know how many lines of code I'm getting up to, but like 5,500 lines of code and comments and things like that so far, at least in this main file. But I might want to come in here and make updates, and I'd like to easily get those updates transferred onto these two chips here. And I don't want to have to pop the chips, put them into a program, or program them one by one, put them back in. I want to do that all without physically having to change anything. So what I've done is I have built a little application, and this little application looks like this. And it allows me to connect from my PC to this Arduino Duo and transfer the BIOS, the latest BIOS information, in other words, this built assembly code from the background here, and put it onto the flash memory of the Arduino Duo. And then from my 286 computer, I can initiate this command that you see on that screen called get BIOS. And it will fetch the BIOS from the Arduino Duo, reprogram these chips on the fly. So previously I showed this application where I could manually choose BIOS, and then I could connect to my Arduino Duo, and I could transfer it by clicking this transfer BIOS button. What I'm going to do here is I'm going to just connect this, but I'm going to leave it off to the side. And I'm going to actually open up my code over here, and I'll just kind of put these side by side for a minute. But let's just say I'm over here coding, and maybe I want to go down to where I'm storing that BIOS version. It's just part of a string. And so I come in and say, I'm going to go to version 2. And today is March 2nd, so I'm going to go ahead and update that. And I'm going to save it. And I have a build script. So down here in this terminal window, I'm just going to clear it. But I have a little script I can call called build ASM. And that script is going to take this file and build it. And maybe let me just show you what that script has in it real quick. So if I look at build ASM, it's going to use a NASM to actually build the file. I then have a utility I wrote that splits it into a low byte, high byte type of ROM, which I'm really not going to need anymore if I'm doing this method I'm going to show you now. I also update the listing file that gets generated to offset everything based on the real physical address that I'm going to be using. And then I wrote a wrapper, a little console wrapper that will actually connect to this Windows form over here and initiate that transfer. So I'm going to just come down here, and I can't zoom into this window down here, I don't believe, so hopefully you can see this, but I'm going to go ahead and run that command. And you notice when I did that, it did all this build and it initiated that Arduino Duo transfer. So just as part of my normal build now, if that background form is running and it is connected, it will automatically transfer. And so in this case, let's see, it ended up taking 19 seconds to transfer that image, which is now on my Arduino Duo. So pretty easy now. And if I don't have it connected, so I just say disconnect. If I come back here and do a build, I'll clear the screen and do a build. It just says that it put in the request basically, but nothing's actually going to get transferred because it's not running. Or if I don't even have that program running, that's perfectly fine too. I can close out of it, and when I go do a build, it just does a build, and then it just says I can't find that program, that process, so I'm just going to skip that step. Again, no harm done. So that's how easy it's going to be to work on getting this updated. And you saw that took very little time, so less than 30 seconds. So by the time I build and I run the script and I even think about shifting over to the 286 itself, it's pretty much on that flash on that device. Now, if I just show you the Arduino Do terminal for a second. So here over to the right, I can see that it processed it and it transferred it and it says done. I have this currently set up so if I hit reset, it'll read out the first 16, last 16 bytes, and I can see what's there. And that looks like that matches what I would expect to see in my BIOS, so I'm good there. But now on my computer, I'm going to just say, you notice when I type help here, one of the options that I have available to me is update BIOS. So I'm just going to simply say update BIOS. And I'm going to press enter. And it says updating BIOS. And at this point, what it's doing is it's going to the flash memory. It's erasing both of them. Then it's going to go out and make SPI calls to the Arduino Do. And it's going to write all of that data down to these flash chips right here. And then when that gets done, if I want to now start up with those new ROM chips, all I have to do then is hit reset on the computer. In this process, I haven't timed it. We can pay attention in this video how long it's taking, but maybe it's a 30-second type of duration. Okay, so that just finished. And let me go ahead and hit reset. And now the system came up and you can see it says I am on BIOS version .0002. Now, you might have seen some garbage on the screen for a second. I was trying to read from my character data that's in my ROM, but because I changed some stuff that moved the offset of that, it couldn't find the right location. No harm done. I'm not too worried about that. I'll maybe come back and try to do something with that later. But it's because I erased... Well, what I did is I moved all of the previous ROM data into RAM. I switched execution to RAM. While I'm running from RAM, I erased the ROMs, brought down the new image, and that new image had some of my character data in a different position, actually how to draw the pixels for characters, so that was in a different position. So what I'll probably do later is I'll go into my source code and set those to always be in the same position. And that way when I get done with my procedure and I go to print more text, that position hasn't accidentally moved. But that's really not a big deal. All I know is that when I hear that second beep, and I'll do another update BIOS here. Update BIOS. So I'm going to run the update BIOS process here again. And in this case, I do have it actually draw it down from the Do again. I'm not doing any version checking or anything like that. I figure I know if I need to do a BIOS update or not. So if I say update BIOS, it's going to go get the latest BIOS. But just as a recap, so from my computer to this Arduino Do, I'm using serial USB, which is theoretically 480 megabits per second. Realistically, by the time I do processing, it's not anything close to that, but it's much, much faster than traditional serial. That gets it down here, and you saw that happened in less than 30 seconds. This update initiated from the user on the 286 is, I'm going to guess, about 30 seconds here. I'm not timing it exactly, but somewhere in that range. And you notice this time, because it could get to that character data, the character data didn't move. It did say complete and reset. And also I know I hear a second beep. So I beep when I start the process, I beep when I end the process, and I put a $sign on my LCD. Those are all indicators that tell me it finished completely. And so if I want to check again, I'll just hit reset, make sure it boots back up correctly. And there we go. So now I'm back up. I am showing a .0002 March 2nd. I can do a ver, which just prints that same thing again, but that is all working. And the rest of my system is working. Mouse continues to work, things like that. So pretty good setup here that I'm liking. I did have to put in between the Arduino Do and my SPI connectivity. I do have a voltage level shifter here, so I'm going from a 5 volt to a 3 volt. That's something with the Do that it does expect 3 volt and not 5 volt. So I have my SPI lines of MISO, MOSI, the clock, the serial clock, and then I also have a chip select. And so chip select's coming over here. Those other 3 lines are coming here, and then I'm pulling this power and ground to go to the leveler. So it's got the low voltage there, and I'm pulling power and ground from my PCB to the other side of the leveler so that it gets the 5-volt side of things. The 2 grounds are tied together, 2 powers are independent, and I'm leveling all that through this little PCB that I have those wires soldered to. And if I want to disconnect these, I put them in little headers, so I can just quickly pop those 3 connections out and move that if I want to. Probably on the next build of my 286 board, I will include this functionality in the board and maybe just make it easier to put this here. And maybe one thing I could do is I did previously have an Arduino Mega built in. I do have it built into the system to do other types of debugging, more low-speed debugging. What I could very easily do is just update the design and put a do here instead of the Mega. Everything the Mega was doing, the do can also do. And then I can also include this functionality. So at low speeds, I could use the do for debugging purposes. At high speed, I could use it for transferring BIOS updates. And it still fits on this footprint. It slides underneath that screen just fine. And even I could do that now. I could easily just set this up here and run these wires up there. That way they would be out of the way. But I'm good with this for now. But maybe that's a future revision to the board. So I am happy. That is a good accomplishment for me to be able to do rapid updates. And so it's maybe a minute or a minute and a half tops. By the time I do a build on my computer, and within 30 seconds it's sitting over here, and then I can initiate it from the system, and that's maybe another 30 seconds. And so that's all a pretty quick process. If you have any questions, feedback, let me know. I will post the current code I have. It needs a lot of safety code and cleanup, and I know there's a lot of efficiency things I can do, especially on the 286 pulling it. That process, I'm pretty sure I can pick up the speed quite a bit. I've put a lot of no-ops in there just to make sure I'm safe on the timing side of things, but I think I can get more aggressive and pull things faster. But I'll post the code I have. You're welcome to give me any commentary, feedback, things that I should be changing. And like I said, I myself have a large backlog of things that I need to clean up in the code, including completely breaking things out into different include files. And I'll start doing that here pretty soon because it's starting to get to be too much for the file that I'm working in today.